Okay, we did our quadratics yesterday, and we're going to start with our square root function that's going to go on our next page here. And these two graphs are related, and that's why we're doing them next to each other. So this one is the square root. And we know a square root sign looks like this. So the x goes inside, and this is equal to y. And instead of just picking some random numbers here, I'm going to tell you some numbers to put in, and it's going to work out so that our square roots are easier for us to do. So I'm going to start here with a -2, 0, 1, 4, 9, 16, 25. So we're going to start over here. If I put this one in, what is the square root of 25? So that's what times itself gives me 25. Well, that's 5. 5 times 5 is 25. Square root of 16 is 4. Square root of 9 is 3. Square root of 4 is 2. Square root of 1 is 1. Square root of 0 is 0. But what will get me a negative number? What times itself will get me a negative? Well, nothing. Nothing works here. So our graph is not going to have any negative numbers, but it's going to start at 0, and then we're going to graph these. 0, 1, 1, 4, 2, 3, 9, and it's going to look like this. And it's going to keep going that way. So what we see is that this graph is related to that graph, because if I take this one and I turn it like this, it's half of that one. These are called inverses, and we'll talk more about inverses later, but notice how this one, it's turned like this, and other than that, it's the same as that one. So now we're going to do our same things we learned before. The domain. Well, the domain goes this way. This is the domain. Well, can I have negatives? I can't have negatives. It starts at 0. And then it's going to go to the positives. So actually, I'm going to write like this. X. And I want x where it's greater or equal to 0. I know it includes 0 because it's got a 0 right there for y. And for x. So my range is going to be the same thing. Range goes this way. There's no negatives, but it starts at 0 and it gets bigger. So the y is also greater or equal to 0. And then my interval notation, again, I'm going to include the 0. And we can look back at our previous page where we had the notations. If it includes the number, I'm going to put the square brackets. So I'm going to include 0. And then it's going to go all the way to infinity. And infinity is the curved one. So it starts at 0 and it goes all the way to infinity. Here. My x and y intercepts, it crosses the x and y axis at 0, 0. Is there a maximum point? No, because this keeps going up. It's going up slowly, but it's still going to keep going up and up forever. So there's no maximum point, but there is a minimum point, and it's right here at 0, 0. That's the lowest point on the graph this way. And then does it have any symmetry? Let's look back at our symmetry from the other day. Here's our 3 choices. Can I fold it this way? Can I fold it that way? Nope, this one can't be folded. And can I turn it to the other side? Nope, it's not over here. So this one has none, no symmetry. And this one also has no asymptotes. Again, we'll talk about asymptotes when we get there. So square root, there's our first kind. Then the next time we're going to do today is absolute value. And you kind of know already that if you put absolute value, there's straight lines like this. And let's just, right here at the top of our page, let's just think for a second. The absolute value of -3 and the absolute value of 3. What does that mean? We have to remember back what that means. Well, it means that I take how far is -3 from 0 on a number line. So if I draw a number line, I put 1, 2, 3 here, and 1, 2, 3, -3 here. How far is -3 from 0 on the number line? Well, it's 1, 2, 3 away. How far is 3 from 0 on the number line? Well, it's 1, 2, 3 away. So what happens is whatever I have inside, my answer is just positive. So I'm going to go through and I'm just going to pick some numbers for x again. -3, so I plug this in here, -3, that's going to give me +3. Plug this in here, I get +2. It just makes each one positive. So now when I graph these, I'm going to graph each point. You see it's actually made a V shape. Remember I said the other day when we did the quadratics that the quadratic was U-shaped and it's curved on bottom. And I said we had a V-shaped one. Here it is. This one is V-shaped. So it's different than the quadratic. Okay, our domain and range. Domain goes this way. The domain is all real numbers. So you remember how to do that. X is an element of all real numbers. So that's -infinity to infinity. The range starts and it's 0 and it gets bigger. So that's going to be y is greater than or equal to 0. So it's going to include 0 because it includes 0 right here. We can see it. 0 and infinity. X and y intercepts. Well, it crosses right there at 0, 0. Maximum point. Well, this one keeps going forever going up. So there's no maximum. But there is a minimum at 0, 0. And symmetry. What kind of symmetry does it have? Look back at your symmetry page. Here's our choices. X, Y, or origin. Well, it has the y-axis symmetry. And this one has no asymptotes. All right. And our last one we're going to do today is rational. And this one, sometimes they call it a rational function. And sometimes they call this a reciprocal function. And we think about reciprocals. Remember what reciprocals are? The reciprocal of 2/3 is 3/2. It's where we flip it over. The reciprocal of 2, the reciprocal is 1/2. So it's where we flipped it over. And that's what this formula looks like. Y equals 1 over x. So you can see why they call it reciprocal. We're going to use the term rational quite a bit later on. And a rational number is just any number that I can write as a fraction. So you see that we're writing this as a fraction. That's why they call it rationals. So once again, I'm just going to pick some numbers for x and y. So now I'm going to plug this into my fraction and it just puts 1 over whatever this number is. So 1 over -3, 1 over -2, 1 over -1, 1 over 0. We're going to come back to that one. 1 over 1, 1 over 2, and 1 over 3. So let's start here. 3 and 1/3. So 3 and goes up just 1/3. 3 and goes up 1/2. 1 and then 1 over 1, that's just 1, so 1, 1. And then on this side I have -3, -1/3, 1/2, 1. So it's kind of curving here, but I can't tell exactly what's happening. So let's first talk about this. We can't divide by 0. You cannot have a 0 on bottom. So this number right here does not exist. We could never have x equal to 0. So right here, we're going to have our first asymptote, and I'm going to take a different color, and I'm going to draw this in because what's happening is I can get close to this line, but I can never cross this line. So this right here is an asymptote. Right here, this line. But what happens as I get closer here? Well, I could pick a couple more numbers. What if I picked 1/2 for x? Well, what would be the reciprocal of 1/2? Well, the reciprocal of 1/2 is 2. So I go 1/2, now it's come up to 2. What if I picked 1/3? What would be my reciprocal? Well, it would be 3. It would go up to 3. What if I picked 1/10? What would be the reciprocal? It would be 10. So as I get even closer, it's going to come all the way up here. So what's happening is it's curving and getting closer to our blue asymptote, but not quite touching. So As it gets closer here, it gets closer and closer, but doesn't touch. The same thing going this way. And then the same thing here going this way. And the same thing going down. So what we see is not only do we have an asymptote here, but also we have one this way. So I'm also going to have one going this way. And again, you may want to draw these in a different color because these asymptotes that I drew in a different color, they're not part of the graph. The graph is just the purple part, but these asymptotes tell me where it gets closer and closer without touching. All right, so our domain. Well, our domain is any numbers except I can't have 0. So we can just write that as x not equal to 0. And the same thing for y. Y not equal to 0. Then for our interval notation, we're going to have to do two different pieces here. I start at negative infinity. And then I go all the way up to 0, but don't include 0. So I put the curve. And then I put a little U for union, because I'm going to put these together. Then I start at 0 and don't include 0, and go all the way to infinity. Then I'm going to do the same thing for the y, because it's the same thing. Negative infinity to 0. Don't include it. Make the curve so you don't include it. Union, and then 0 to infinity. All right, my x and y intercepts, there's none. It doesn't cross at all. Maximum and minimum points, it keeps going up and it keeps going down, so none. Symmetry. If we look back at our symmetry, we'll see what kind of symmetry does this have. It's the origin symmetry. So this is the origin symmetry. And finally, our asymptotes. We need to tell where these blue lines are. Well, this one is on the line x equals 0, and this one is on the line y equals 0. So this is our first one that's had asymptotes.